Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm gonna solve some cosine equations using algebra. So what we're gonna do here, we are looking for an angle. So that is between, we're looking, I'm just gonna write down for x that is between 2 pi and 0. So when cosine is equal to of that angle square root of 2 over 2. So this is our angle. So I'm just going to copy down all of it. So I'm going to go 2x is equal to, and now I'm going to use unit circle. So we're talking about cosine, and cosine is our x coordinate. So we're looking in first quadrant and the fourth quadrant. So square root of 2 over 2 is here and square root of 2 over 2 is there. So we do have two solutions already. So one is pi over 4 and another one is 7 pi over 4. Now, and this is between 2 pi, so it's like 2 pi. So, but we do have two x's, not one x. And I'm going to add here 2 pi k, because sometimes we do have to consider angles that are outside the required domain. If you're looking, sometimes you're looking for infinite solutions, so there is no domain, or finite solution within domain. So I'm just going to show you, if you're looking for more solutions or outside this domain, how you can find them. So k is an integer, so that can have value of 0, plus 1, 1, plus minus 1, plus minus 2, and so on. So now, as we have 2x on this side, what I'm going to do, in order to get rid of this 2, I'm going to multiply by half. And remember, in solving equations, when you multiply one side by a number, you have to multiply every single term on both sides, so, which I'm doing just here. So this is going to give me, this is gone, I'm going to end up with x equal to pi over 8 and 7 pi over 8. And now plus 2 and 2 gone, pi k. Now if I consider for k equal to 0 and I substitute here, so this is eliminated, so it's gone, we're going to end up with, those two solutions. So this one here, so this one here, and this one there. So we have two solutions already. Now we have to check the values when k is equal to 1, and just to see, what's happening there. So x is going to be equal to pi over 8 plus k, substitute, it's plus pi. So it's going to give us 9 pi over 8. Another one, x is 7 pi over 8, which we are going to take from here. So here, okay, and then plus. So plus pi, it will give us 8 over 8. 8 and 7, is it 15? Yep, I think so. 15 pi over 8. So let's have a look at those two before we move on, and before we check k equal to 2. 9 pi over 8 is a little bit more than 1 pi, so it does look like that this is our solution as well. 15 pi over 8 is a little bit less than 2, very close, but not 2 pi yet, so this one is our solution as well. So let's just check k equal to 3. So we're doing the same thing. So we're doing x is equal to, from here, pi over 8. So pi over 8 plus this k equal to 3 will be substituted there. So it's going to be 3 pi equal to. I'm going to do the same for this one here, 7 pi over 8. So 7 pi over 8 plus 3 pi. Now, I'm not going to be even bothered calculating this because I have 3 pi here and 3 pi there, which means we are already outside the domain. So therefore, those two are not solutions for this question. Okay, Now, that would be all for this example. Let's move to another one. Okay, here we have this example, cos to the power of 2x is equal to half. But before I start explaining how to solve this one here, I'm just going to write something here in the corner. So please note, solving cos of x equal to square root of 3 over 2. It is similar to example we did before, but if you want something even more similar, have a look at solving sine equations algebraically that I have recorded before, and it's very similar. It's just you're dealing now with cosine instead of sine. Now, let's have a look at this question here. Here also what I would like you to note that cos to the power of 2x is actually the same as cos x and everything, oopsies, everything to the power of 2. So often I deal with, this expression because it's easier for me not to make mistakes and stuff like that. So, and for that reason, I'm just going to rewrite this. I'm just going to put cos of x, everything to the power of 2 is equal to half. Now, again, as you know, in algebra, so we're going to get rid of square root on both sides by, we're going to get rid of the power on both sides by taking square root. So these two square root gone, we end up with cos of x and is equal plus minus square root of 1 over square root of 2, which is plus minus 1 over square root of 2. Now, the domain for this one here, it is, let me find blue color. Come on, yep, you're here, beautiful. So x is going to be between 2 pi and 0. So this is our domain. Now, cos of x is equal to plus minus 1 square root of 2. So pretty much we do have to look for two solutions. Cosine of x is equal positive 1 over square root of 2, and cosine of x equal to negative 1 over square root of 2. Now, cosine is our x coordinate, 1 over square root of 2. So, and that is, now, looking at this unit circle, you won't find the same answer. So they look a little bit different. So what is happening here, it's 1 square root of 2 times square root of 2. So we are getting rid of the third in denominator. So, and we do end up with this expression. So pretty much this here is the same as that one there, okay? So which is what we have here when pi over 4 and 7 pi over 4. So therefore the angles with cosine 1 over square root of 2 are x is equal pi over 4 and x is equal to 7 pi over 4. So this is one solution and here's another solution. And cosine with the angle with cosine of negative 1 over square root of 2 so where are they? They are on this side. Let me just choose a yellow. So it's now here and there. So what are we looking for? It is x equal to 3 pi over 4 and x equal to, can't even see this one here, 5 pi over 4. Now, I'm not gonna try to substitute, k equal to 0 or 1 or 2 because we can see here it's only, it's 2 pi, So it's 2 pi, and we already have, like, if we start from here, if I start from 0, then I have one solution, 2, 3, 4, and that's already 2 pi. So we don't have to check, one more period. So I'm happy with those solutions. I'm just going to circle them. This is the one here, another one, third one, and the fourth one. So that would be all for cosine functions. So I hope you enjoyed watching this, and thank you for watching, and I'll talk to you soon. Bye.